All right, today we're digging into the incredible story of metals. And I mean, this is a revolution that literally shaped our entire history, all the way from the first shiny piece of gold someone found to, the aluminum can that might be sitting on your desk right now.
Seriously, just take a look around you for a second. Right now, how many metal things can you spot? Your phone, right? The zipper on your hoodie, the legs of your desk, maybe even the chair you're sitting in. It's kind of crazy when you think about it. Metal is just everywhere. And yeah, I mean that literally. We are living in a world built with metal. You've got the giant steel beams holding up skyscrapers, the tiny copper wires bringing us electricity. Metals are basically the invisible skeleton holding our entire civilization together. But have you ever stopped to think about where all this stuff actually comes from? Because here's the thing, you don't just, stumble upon a big chunk of pure iron or aluminum out in the wild. It doesn't work like that. Most metals are actually locked away, chemically trapped inside rocks. And really, the entire history of human technology is the story of us figuring out how to get them out. So let's talk about that. How do we unlock these treasures from the earth? Well, it all starts with these special kinds of rocks. They're called ores. So what's an ore? Simply put, it's a rock that has enough of a useful metal inside it to make it worth the effort of digging it up. Like bauxite for aluminum or hematite for iron. These are the starting point, the raw materials for pretty much every metal we use. Okay, and this is the main idea I want you to hold on to. Think of every ore as a locked treasure chest. Inside is the metal, that's the treasure. But, and this is the important part, not all locks are created equal. Some are super simple to pick, while others are like high-tech vaults that need a seriously powerful key to open. So, over thousands of years, humanity has basically invented a set of 4 master keys to get into these treasure chests. They go from, super simple to wildly complex. And the key you need, it all depends on just how stubbornly that metal is locked away in its ore. Let's break them down. All right, key number 1 is, it's basically just muscle. It's physical separation. For really unreactive metals like gold and silver, the treasure isn't even really locked away. They're often found as free elements, meaning they're just hanging out, not chemically bonded to other stuff. So all you have to do is separate them from the dirt and rock around them. Think about panning for gold in a river. That's it. Dead simple. Okay, moving on to key number 2. Just add heat. Now, for a metal like mercury, which you find in an ore called cinnabar, the lock is a little bit tougher, but it's still pretty weak. All you gotta do is heat that rock up in the air, and that heat is enough to snap the chemical bonds and set the pure mercury free. A little more advanced, but still pretty straightforward. Now we get to key number 3. And this was a huge leap forward, a real game changer. For tougher metals like iron, lead, and zinc, just heating them doesn't do a thing. The chemical lock is way too strong. So the big breakthrough was figuring out that if you heat the ore with something else, specifically carbon, like from charcoal or coke, the carbon literally rips the oxygen away from the metal, setting it free. This whole process is called reduction, and it's the magic that happens inside a blast furnace. This key right here is what gave us the Iron Age, a massive deal. But what about the Fort Knox of ores? I'm talking about the really reactive metals like aluminum. These guys are locked down with insanely strong chemical bonds. Heating them with carbon? No, not gonna cut it. For these, you need the ultimate master key, electrolysis. This is pure brute force. It uses a massive jolt of electricity to literally tear the metal atoms away from the other elements in the molten ore. It's incredibly expensive, it uses a ton of energy, and it's a key we only figured out how to use pretty recently in human history. Okay, so we've got our 4 keys, right? Physical work, heat with carbon, and electricity. And they were invented in that order over thousands of years. Now, here's where it gets really cool. The difficulty of using these keys. It perfectly explains the timeline of human history. I mean, just look at this. It lays it all out. Gold, we've known about it forever, since ancient times, because you only needed that first simple key. Iron, that came way, way later, around 3000 BC, because we had to invent the much more complex carbon key, the whole blast furnace thing. And what about aluminum? It was a complete mystery until 1826. Why? Because we had to wait for someone to invent electricity and figure out how to use that final, most powerful key. So this is the big takeaway, right here. A metal's role in history had nothing to do with how useful it was or even how much of it was around. It was all about its chemistry.
It was all about how hard it was to pick the lock on its treasure chest.
And if you need proof, check this out. What do you think is more common in the Earth's crust? Iron or aluminum? You'd probably guess iron, right? We've used it for so long. But nope, it's aluminum. And not just by a little bit, it's the single most abundant metal in the entire Earth's crust. So think about that. The most common metal was completely useless to us for most of human history, all because its treasure chest was just too damn hard to open.
And this whole difficulty thing isn't just ancient history. It has a massive impact on the price of metals and the energy we use to get them, even today.
Let's just compare the two. Getting iron using that carbon key? I mean, a blast furnace is hot, sure, but it's a technology we've had for thousands of years. It's relatively cheap. But getting aluminum using electrolysis? That requires an absolutely insane amount of electricity. It's a hugely expensive, very modern process. So yeah, the key you need basically sets the price tag. So, okay, we've gotten really good at unlocking all these metals. We have all the keys, but that creates a whole new problem, right? The ores in the ground, they're not infinite. There's only so much. And that brings us to the next chapter in our story with metals, what we call closing the loop. Just let this number sink in for a second. 95%. That's how much energy you save by recycling one aluminum can instead of making a new one from ore. 95. And why is it so high? Well, it goes right back to our analogy. When you recycle, you get to skip the hardest, most expensive part of the whole process. The treasure is already out of the chest. You don't need to use that super expensive electric key all over again. And I mean, the benefits are just huge. We're not using up the finite ores in the ground, we're saving incredible amounts of energy, and we're not creating all the pollution that comes from mining and extraction, like sulfur dioxide. Plus, we're not filling up landfills. It is just a massive win-win-win all the way around. But, okay, let's be real. It's not a perfect system. It's not free. There are real costs involved in collecting all that scrap, shipping it around, and sorting all the different metals from each other. And maybe the biggest hurdle of all, it only works if we actually take the time to put that can or that piece of scrap in the right recycling bin. And that kind of brings us to a final big question. We literally name huge chunks of our history after the metals we've figured out how to use, right? The Bronze Age, the Iron Age. So as we get smarter about not just extracting materials, but reusing them, what's next? What material, or maybe what idea, is going to define the age that we're living in right now?